Thank you again for coming to another seminar. Today we have Elena. She's a PhD student from Italy, and she's collaborating some weeks here in a project with Juan, and she's visiting us for some weeks. So now she will explain a bit of her research. Thank you very much for the seminar. The floor is yours.
Thanks. Thank you. So,
yeah.
Work? Okay.
No, it's the things that now I think it's in no? Yeah.
Fine. Okay. And so, yeah. Hello, everyone. I'm Elena Allegri. I will speak about my PhD project and my PhD research in general. I'm a PhD candidate in science and management of climate change at Campus University, and I also collaborate with the Mediterranean Center on Climate Change, MCC. I have a background in environmental sciences, and my research topics focus on climate adaptation, mitigation, risk assessment, nature-based solutions, and adaptation pathways in general. I just give you say a few things about the Mediterranean Center on Climate Change. That's this research center leading on the climate and society, and its mission is to investigate the connection between climate systems and the society, and providing results that can lead to different sustainable growth, protect the environment, strategies, and from different perspectives. We have offices all around Italy. I belong from the office in Venice. And we collaborate also with different institutions, universities, and research centers. And we are an interdisciplinary research center with different divisions. My division is RAS, on risk assessment and adaptation strategies. And in each division, we focus on many different aspects. We have the climate simulations, agricultural aspects, hydrological models, economic impacts. So we cover many aspects of climate change. We have also a supercomputing center that is based in our headquarters in Lecce, and with large storage capacities and processing capacities. It is one of the biggest European supercomputing center. And then we do many activities, many outreach activities, like publications, of course, and then communication events, educations. We have webinars continuously that everyone can join by subscribing to the different pages covering different topics, and they are super interesting. We have different also channels and podcasting on Spotify. Called Foresight Dialogues. Yeah, that's super interesting. I really encourage you to listen it. It's in English, so it's fine. So that was my research center I belong to. And Macovias is the project, is a European funded project, Horizon Europe 2020. And it focuses on the connection between marine coastal ecosystems, biodiversity, and climate change. The Macovias project has a consortium of multiple university and research centers all across Europe, but also overseas. We have some partners in the Caribbean. And to foster our research, we have different case studies that are for European interest, let's say. So we have the case studies in UK, Ireland, and Norway for the Northern Europe. and case studies in Italy, France, and Spain, in Mallorca, Malta, yeah. And then overseas case studies in the Caribbean with Barbados, Martinique, and Bonaire. In all these case studies, we focus on 6 main ecosystems, ranging from coral reefs, kelp forests, seagrasses, salt marshes, that are the focus of our researches. Okay, so I just give you a bit of background of this project, why we developed this project is basically almost 40% of the world population lives along the coast, in which billions of people live there and directly depends on ecosystems and the services they provide. That means in terms of food, livelihoods, recreational activities, and also coastal protection, coastal erosion. However, these marine coastal ecosystems are threatened by multiple pressures, climate pressures, and human pressures that affect our ecosystems and create this negative loop and their ability to deliver the services we need. So basically, the overall concept of Macrobius builds on the ecological condition concept and the indicators that define it. These indicators have been developed like in the literature unknown, but they have always been considered like compartments. While here in Macrobius we try to give a global understanding of the ecological indicators related to biodiversity and ecosystems and their services. And for doing that, important key points that we highlight we try to understand, to unravel with the project relate to the marine and coastal ecosystem monitoring to guide policy and decision makers in developing their plans and to encourage the implementation of nature-based solutions to face the impacts of climate change. And finally, to drive the marine spatial planning and all the decision policies at different stages. So this is the 4 work package, 5 work packages of the project. I've been working more related to work package 2 and 3, related to the risk assessment, so the definition of the cumulative impacts and affecting our ecosystem, marine coastal ecosystems, and then on the definition of nature-based solutions and their effectiveness to provide these services and facing the different impacts. So basically what I was telling you is, and that's behind our project, my PhD, is that the concept that climate change and environmental degradation are affecting marine coastal ecosystems. So we need to, and the services people rely on. So we need to change the transformative way to adapt in order to preserve and restore our environments. And nature-based solutions can play a crucial role in this regard, since they can provide also services and benefits to the society. In Macrobius, we did so engaging the stakeholders and identifying some questions to which we find an answer to different modeling approaches. Like we try to answer to why, where, and how through multi-risk assessment, a suitability mapping model, and a decision tree. for the NBS and to provide overall, finally, a NBS portfolio that enhances the resilience of marine coastal ecosystems. And we did that, as I said, with stakeholders' involvement. We started with identifying the pressures that affect the ecosystems, the ecosystem functions and the biodiversity, and the social challenges that we need to face to our ecosystems. So the pressure, we first identified the cumulative pressures through a multi-risk assessment model, while we identify where to implement, where to ecosystem function can work properly, and then to which such challenge to answer with the decision tree. The case study for this multi-stage conceptual framework has been the Mediterranean Sea, and since it's a hotspot of climate change, biodiversity, of many aspects, so our models are at net scale. With the multi-risk assessment, we try to unravel, to understand what are the mechanisms by which the different pressures, climate and human, affect our ecosystems. And we make this to a machine learning model, but playing with the baseline scenarios and future scenarios of climate change. So with different conditions like the rising temperature, the rising sea surface and temperatures, variation in salinity and sea level rise. And here we see what are the, basically we assess the shrinkages of seagrasses in the present and in the future, with different RCP scenarios. Then we try to understand where the right place, the right conditions, environmental, socioeconomic, governance, in which implementing our solutions, in which implementing the NBS. And here we developed a suitability mapping model for the baseline and for the future scenarios, again for 2050 and 2100. And so we basically understand what are the conditions, what are the areas that are suitable for Posidonia growth and health. And we projected where in the future which area will be suitable for their growth according to changes in temperatures, in climate conditions. And yeah, that's basically our results. And then finally, once we have identified the why and where, so the two models, how we can intervene, what type of actions we can undertake. And we did so with the decision tree that provides a portfolio of potential interventions. So basically, we start with identifying the social challenges, so what we want to answer, what we want to preserve, and the related ecosystem goods and services, so which services can answer to our needs, and that connect to the ecosystems. So what is seagrasses, salt marshes that provide these services, this function, and then at what scale we can preserve them, and which kind of action we can undertake. So restorative action, protection actions, other management actions. Once we have identified that, now is to better define the nature-based management solutions And we do this involving the stakeholders directly and designing a Bayesian network model, that is a statistical model basically, that varies over time and space to evaluate the multi-risk that lead to water quality degradation, environmental degradation, and to find management actions that we can undertake to reduce these risks. And this is actually the work that I'm carrying on here in Medea, with the support of Julia. Yeah, the case study, like this model will be repeated, will be applied to three different case studies at southern Italy for Apulia region, in Spain for the Menorca Channel, and in the Caribbean for southern Martinique, with different ecosystems. I'm focusing on seagrasses, you will focus on marbles and coral reef in the Caribbean. So we started with by identifying the key pressures that affect our assessment endpoint, that are the seagrass meadows density and the services, their functions and services they provide to us. So we kind of create this mind map that links everything, the management solutions with more environmental data, with more human pressures, and with a cascading effect, how one has an effect on the other. And yeah, as I said, my case study for my PhD is the Apulia region, and we are considering data from the Water Framework Directive that has continuous monitoring, so it allowed me to have different data for different years. And yeah, we are considering both transitional waters and marine coastal areas. And all the data that the Water Framework Directive is not able to provide me, we are keeping from Copernicus, Hermotenet, qualitative data from stakeholders, local authorities. So here is like we made some first tests by selecting only some variables, like more interesting one, let's say, that we can see have a direct impact, and also to test the model to see if it works properly or not. So with the red boxes, I highlighted the nodes we selected. And we did a workshop. We collected also qualitative data, since not all data are available from portals or whatever. We collected some qualitative data through our local stakeholders in Puglia, that are yeah, for having knowledge on things that are not so like evidence. And yeah, this is the simplified version of the test, and here is some visualization of the model, since we are using Netica software for making this Bayesian network. And yeah, basically here are all the different nodes that show the classes in which our data set is split, and how they contribute to the assessment endpoint. Once we have defined the baseline scenario, we will play with future scenarios to imagine different what if conditions. So on one side, we will play with climate change scenarios. We will change by climate variables for under different RCPs and 2050, 2100. And in parallel, we also play with these different management scenarios. And to create this matrix in which implementing some management actions, we would like to know at least how much it benefits my ecosystem, my Posidonia. And in doing this, we link also to what I showed you before, that's the decision tree, so the type of actions we can do. And also we basically create our management scenarios directly with our stakeholders. So that allowed us to create this infographic, and in which we identify first the main pressures affecting the case study area. And then through their expertise, we identify our first scenarios, that is the infrastructural development with all the effects it creates, so what they are suggesting in terms of compensating. A second scenario, that is, we call it carrying blue protections, that focus on protections, on implementing, enlarging the MPAs that are already present, and the site of community importance. I don't know if that is the name in English, but in Italian I call the SIC. And what this kind of action means. So in terms of protecting, like regulating the selective fishing, the dredging activities, mooring activities, and this should help to achieve the SDGs, the objectives of the SDGs, like having 30% of the European Sea protected and 10% strictly protected. And then we have the third scenario, that is the backcasting targeting a shared goal, in which our stakeholders suggested us to have an active restoration approach. So basically managing urban sewages, having direct active actions for habitat restoration, and this would help also to achieve the SDGs, to protect the ecosystems, and also this implies to involve local communities, cooperating with them, having managing authorities that supervise these activities, as well as in the carrying blue protection scenario. And also this would help to achieve the environmental good status that is required from the Water Framework Directive and the Marine Strategy Framework Directive. So yeah, to sum up a bit what I show you is like basically the objectives of the Bayesian network model is to disentangle the complex interrelationship occurring between biodiversity, ecosystem services, climate change, and understand all these relation that is also the core part of Macology's project. With the Bayesian network model, we want to build these what-if scenarios to test in different conditions, climate and management solutions, to then provide a tool to provide information useful for decision planners and decision makers in the management of the environment, marine environment. And at the same time, all the multi-stage framework that we identify within the project wants to be a guide for decision makers, especially in their planning and implementing of NBS, nature-based solutions. By providing them at the same time a portfolio of possible solutions. So like the tools on where to do that and what to do. And yes, for doing all these type of activities and information, it's really important for us to engage, involve the stakeholders to understand their needs, their perceptions, and integrate that in a integrated manner. So yeah, that's why we are continuously working with them and developing things with them. So yeah, that's it.
I have a question. If I understand well, what you have is, in a sense, a system to analyze what you have and make predictions of how things might evolve, taking one or another sort of mitigating measures. Yes. But you make predictions, but is there a dimension? What I didn't see is the dimension of testing of your predictions, right? I mean, you can make predictions, but maybe they are completely wrong. I mean, how are you sure that the prediction that you make should be? How are you sure that? Or how are you testing whether the predictions that you make are reliable?
Okay, so we will make climate change scenarios predictions that will be based on climate models, like models developed from my institutions, MCC, and European models, so that I've already kind of security, let's say, in the bracket.
But as well, I don't work on this at all, right? Is there how reliable are these models at the small scale? Right, you're looking at pretty small scales here, right?
Yeah, it's region. No, yeah, local scale, region in Italy. Yeah, it's a small scale. Yeah, we can say. Well, the models that we have are reliable, and we think are reliable. And then this work with the stakeholders is something that we build with them, so they know, they have the knowledge on the ground. Let's say they know what are the things are needed, what is ideal to protect, to manage, to do or not. So it's something that is built with them, with their needs and perspectives, and this is a kind of also a benefit of a positive effect of this management scenario. So this allowed us to make them more realistic, not only ideas saying we would like to achieve the targets that Stewart says. So since it's are co-developed, that's a strength of our model of what we predict will be. And yeah, yes, they combine with the climate model that are realistic with what we have or different models.
Yeah, well, one of the pros I see there is that you actually are estimating what's the response of an ecosystem in a future scenario based on how it functions right now. That the structure and the functioning will be the same in another scenario. So it's difficult. So my question goes, you say that you wanted to increase the resilience. So how do you measure the resilience of an ecosystem?
Yeah, that's a good question. Well, in our model, like we are seeing, like for building the baseline, we are not considering only 1 year. We are considering more years, and that allowed us to understand if how the pressure changes over the years, and if our in our case ecosystem is behaving basically. And so it doesn't say the resilience of the ecosystem, but it allows us to understand if it can remain or not. Also with the suitability mapping model, allows us to understand a bit more of its resilience, because we assess the conditions, we consider different variables, climate, water qualities, and geomorphological variables.
That you only estimate the resilience of a population of Posidonia, not an ecosystem resilience.
Yeah, we are focusing on Posidonia.
So,
Because it depends also on the variability, and we are not making fieldwork activities and that, so all the data we have are based on portals, European portals, and local things. Yeah.
In all that topic was actually covered by Wolf Akachwan. She was not so involved in that. It was the ecological
no,
one.
I didn't want me
No,
to
but-
focus on it, but on the general process.
Topic of resilience was very much discussed all through the 3 years of the work package. And in fact, at some point in the project, we decided to not talk about resilience anymore. We talk about a safe operating space. So the ecosystem or the habitat found in a species is within a safe operating space. So it keeps providing the functions it should provide and the services. So which are the limits of this? Temperature, acidification, whatever, to still provide the functions. But the resilience is very hard. In fact, it was not more a philosophical question sometimes.
Yeah, also for the suitability modeling, we define this safe operating space with these boundaries in which we know Posidonia is present, and above which we know, or we suppose Posidonia wouldn't really survive.
I was wondering if, because you've had to gather a lot of data from other variables and processes. Have you detected any gap in our knowledge, or any particular variable that is undersampled, or any process that is not properly known to what you want to do?
Yes, we had many issues and troubles with collecting data and reprocessing, working with them. Yeah, would say that we saw some gaps in the biogeochemical, exactly, processes and gaps in the data we have, especially when we were developing the multi-risk assessment model with the machine learning tool. Because we saw there were so many missing data regarding especially Posidonia, and many like inconsistent, let's say, monitoring of the different variables we want to include that are relevant for the growth of the ecosystem. So we couldn't simplify too much, because otherwise we know it's not realistic. We saw that there were many gaps in terms of collections of data, in terms of years, and also in terms of resolutions. Now, indeed, we are starting working with satellite images, but also here there are many problems, and we are a bit struggling. So, like in general, yes, it's we had to do many compromise in terms of, for instance, like the length, the time period to consider, the future, what type of information we have, which projections we have, and limited knowledge on biogeochemical processes from what we want to assess, especially in relation to the water quality, and also in relation to the ecosystems. For what I'm doing for my PhD, I've seen that there are really few data and knowledge on the potential of NBS in acting in ameliorating water quality, limiting water quality degradation. So like all the data, neither data, but all the knowledge that is available is based on experiments and not really real case implementation. It's really, really limited. It's what emerged from my research review. And this is a gap in the knowledge. This is something that we are not really testing on, like in general science is not really testing the benefit on ideas related to water quality. So,
I have a very naive question. So you said around the time during the talk that you work a lot, side by side with the stakeholders.
yes.
And I was wondering, like from ignorance, in this context of ecosystem managing, who are the stakeholders?
Yeah.
Like which kind of figure it is the figure you work with?
We are working for our case study. So in Puglia, we are working with the environmental agency. Like in Italy, every region has an environmental agency, and with them, they are making all the monitoring activities. So they perfectly know how the environmental system works for the region. We are working with, like we have some MPAs. We engage them because they like the management of protected areas. Then we have Legambiente. Legambiente is
Yeah, I know.
okay, good. And then we have we try to engage, that was a bit hard, but we are also going to get them with us on board. The institution, like the regions, we had some talks with guys from the regions and the environment offices, the municipalities. We also try to engage, real fast, yes, like the like yeah, like the communities of like the touristic activities that are managed, like the authorities that manage the touristic activities. Then what we have, yeah, all the recreational we try to have, but we're not really successful in that. I mean, there are some limits from our side, recreational activities along the coast. But yeah, the key person figure were that one.
Because it's not like something that someone who has a direct economic, in the last cases, yeah, but it's not someone who has a direct economic venue from the system. Like we talked about stakeholders.
No.
People making money out of like a marine ecosystem, but if you talk about the
somehow yes, no, somehow like with the part of the tourists, let's say with the like you know the in the beaches where
yeah,
like this exactly, they have an economic income from, they benefit most from directly, let's say, from the ecosystem services. But then they were mainly authorities, local authorities, yeah.
And from your stakeholder interaction, what do you think is the measure they encourage, the protection measure they encourage more?
Like among these scenarios that we built with them, from our experience, the caring blue protections, like they talk about a lot about NPAs. Maybe it's because we're a strong presence of people from NPAs, so they were strong, let's say, in the discussion. But also like the infrastructural development, since there are already many plans that are going, that are set up, they saw that's a thing that it will happen for sure. And so they were saying the compensation, since there are rules that when you build something, you have to compensate. and they were pushing a lot in this aspect of compensation and the type of compensation. And here there were this a point of disagreement between the different stakeholders. But I would say the first two were maybe, yeah, focusing most.
You know that in Europe now there's the restoration law that's what is like 20% of all. Do you think that's feasible in the marine environment?
I don't know, because like I'm not that sure honestly, because also with the objectives of the SDGs 2030, we are quite far away from achieving that. So it's like another objective that somehow to be achieved. So I'm not that sure. Yeah, so because there are many things going on, and yeah, they are also here for this area. They are speaking about creating a huge offshore wind farm that even if it's really far away from the coast, but still it requires infrastructures and that belongs to it. So yeah, that's
Okay, so we can leave it here or continue with some years after. Thank you very much, Elena.